MJOs and ENSO had been a hot topic for a while, especially because El Niños tend to have these so-called westerly wind bursts associated with them. This is an example from 97-98 El Niño, which was one of the strongest in the 20th century. You can look at other El Niños as well. You can look up my lectures on El Niño in other courses to learn more about this. But essentially, exactly what these westerly wind bursts are is still not totally clear. Often they are assumed, they seem to be part of MJOs, and sometimes they seem to be winter surges from higher latitudes and so on. But nonetheless, considering that they are in the MJO season, especially here in the October to December and up to April, but during an El Nino they are also active during the boreal summer months where we don't have MJOs. But then the question is whether El Nino facilitates the MJO season to continue past April into May, June, and whether that can explain the monsoon droughts, because instead of the eastward propagating systems detouring northward into the Bay of Bengal and bringing rain over India, are they being made to go eastward and create drought over India and so on. Nonetheless, the basic argument there was that the westerly wind bursts push the front between the cold tongue in the east and the warm pool in the west, and they send off Kelvin waves. You can see Kelvin waves associated with these westerly wind bursts, and the downwelling Kelvin wave pushes the thermocline down on the east. Rossby waves lift the thermocline to the west, and the westerly wind bursts become larger in the fetch and duration, and they can become stronger, and they are not noise anymore. They are part of the signal of the El Nino by feeding back to the El Nino itself, modifying the convection moving eastward and the westerly wind bursts extending behind them, and that is called multiplicative noise and so on. So in general, the MJO and El Nino argument had been focused on this idea of whether the El Nino is an unstable oscillating system, or is it a stable system which needs a kick like the westerly wind bursts or MJOs? Does every westerly wind burst start an El Nino? Obviously not. So what other ingredients are needed, and so on and so forth. But in the context of MJOs, some other ideas are emerging. This is from a paper by Bin Wang, which now defines Mjo Diversity, which is modeled after what we call Enso Diversity. So Enso has multiple flavors, can be extreme El Nino like the 97-98 El Nino, which is very much focused on the east along the coasts, or canonical El Nino, which is much more in the central eastern Pacific, and there is something else called the Central Pacific El Nino, which tends to be focused on the dateline. Along the similar lines, now he is defining Mjo Diversity. So looking at 1983-84 example of diversified propagation patterns of MJO, basically looking at OLR. So this is Haumüller diagram of interseasonal OLR averaged between 10 south 10 north for 1983-84 boreal winter and 96-97 boreal winter. So both are strong MJOs, strong El Ninos, and just as I said, as westerly wind bursts may or may not be MJOs, this paper is directly interpreting the westerly wind bursts as MJOs. So you can see that the 83-84 El Nino was associated with MJOs that didn't make it so strongly into the Western Pacific across the maritime continent, whereas during 96-97 they propagated clearly into the West Pacific and past the dateline, as we saw here. Okay, so taking that further, he looks at 4 types of MJO propagation patterns along the equator. So the standing mode, which gets stuck on the Eastern Indian Ocean side, you can see the number of cases during the period of study. And the second case is where they seem to jump, so they come to the Eastern Indian Ocean and they reappear on the western side with a kind of a disappearing act on the maritime continent, whereas there are slower propagating ones that are continuous across the maritime continent into the West Pacific. As you go past the dateline, the temperatures are colder, so the convection dies away and the OLR signature doesn't exist. And there are fast cases. You can see the propagation speed is different. It's 3.5 meter per second here and 5.4 meter per second over here. I would be careful about this because there are times when MJOs clearly get detoured and go between Indonesia and Australia. So when you average over 10 south, 10 north, you are probably misinterpreting some of them as stranded or standing modes on the Eastern Indian side. So I would always want to be careful about that. Nonetheless, this shows background SST anomalies associated with the 4 MJO clusters: the standing mode, the jumping mode, the slow propagation mode, and the fast propagation mode. Obviously, if they are associated with El Nino, then they are going to project onto El Nino and have a definite coupled ocean atmosphere feedback as a part of the El Nino, as part of the multiplicative noise, as we said. Okay, so I will leave it there, but there is another paper which looks at how the Eastern Pacific El Nino and the Central Pacific El Nino actually affect MJOs. So here, instead of thinking of MJOs affecting El Ninos, this paper is arguing about El Nino affecting the MJO. Okay, so this is the OLR anomalies which are taken as MJO strength. So you can see here, going from July to May of year 0 to year 1, for an Eastern Pacific El Nino, which is focused, the warming is focused over here, and it has a much stronger OLR signal, so stronger weaker MJO growth rate, whereas here the Central Pacific El Nino is argued to provide a stronger MJO. Okay, which is it consistent with this one? So the fast propagating mode is producing what looks like a Central Pacific El Nino pattern, whereas the standing pattern here seems to be much more like a Central Pacific El Nino, but actually it has negative sea surface temperature anomalies associated with them. So whether that's related to El Nino termination and transition to La Nina, or whether it's related to creating anomalies on this side which create strengthened upwelling and so on, are questions that you have to read this Bin Wang paper to figure out. But nonetheless, it does leave you rather wondering about whether El Nino and MJO are completely independent when they co-occur. Obviously, MJOs occur during most years and they don't always produce El Nino. So the question then is, how does MJO affect the El Nino? And whether El Nino itself can affect the MJOs also, or whether they are having some sort of a feedback, amplifying each other or weakening each other, and whether the warming near the dateline and in the East Pacific are different El Ninos which affect MJOs differently, or are the MJOs themselves able to produce different flavors of El Nino. Okay, so Dynamo would say that the air-sea interactions are not the same in every MJO, and there is also the remote forcing that I mentioned, where Kelvin waves can propagate eastward, and downwelling and upwelling Kelvin waves can propagate eastward and create colder background SST or warmer background SST, which can then favor Bjerknes feedback, which basically Bjerknes feedback means SST anomaly in the East Pacific changes the east-west sea surface temperature gradient, which changes the east-west pressure gradient, and because you are in the deep tropics, Coriolis is weak, you get a fast wind response, which has a positive feedback on the original SST anomaly. For example, if the SST anomaly is warm, it reduces the east-west gradient of temperature and pressure, which produces westerly wind anomalies or weakens the mean easterlies and enhances the reduction in upwelling, warms the SST further, which further weakens the temperature and pressure gradients and so on. So you get a growing feedback called the Bjerknes feedback. So this is a good case of understanding MJO coupled ocean atmosphere feedbacks within MJO, but how the MJO itself may be affecting the El Nino as well. And in the model, again, interpreting this impact of MJO on ENSO can be tricky because models have a mean state bias, and when there is a El Nino, the mean state bias is actually reduced. For example, model has a cold tongue, colder than observed cold tongue. El Nino warms in the east and reduces the bias, which actually can affect its MJO. So you might end up over-interpreting the MJO impact on El Nino or the El Nino impact on MJO. So if they are done from observations, it's not always easy to separate them. If they are done from models, then one has to be careful about how model biases themselves affect the interpretation of MJO and ENSO interactions. Okay? Tough business, but as I said, we keep making progress with observations and models and process studies and simplified models and GCMs and so on.